Welcome to Tech Transforms and happy holidays. I'm your host, Carolyn Ford, and today's episode is a special gift, not just to me, but to anyone who's ever worked in data security or standards. We're joined today by Mike Beckerle, Chief Software Architect at OWL Cyber Defense, co-creator of the Daffodil standard. Mike, when it's DFDL, do you say the acronym out or do I say Daffodil?
Yeah, it's a little confusing. Thanks, Carolyn, for hosting this. And welcome to all the people who listen and view this. So DFDL stands for Data Format Description Language. And a
Okay.
long time ago, when that acronym was first coined, someone said, yeah, we can use daffodils as our logo and pronounce it daffodil, right? Then
Okay.
someone started an open source software project
Mhm.
and they about an implementation of this and they named it Daffodil spelled out, right?
Okay.
And this has done us no favor, of course, because
This
the
is
two
really
are
hard.
tightly related, but different things, right? One
So
is
do
a spec, the other is
yeah.
a body of software.
So when I see the acronym, do I say DFDL or do I say daffodil?
I say DFDL.
Okay.
That's what I've chosen to do because I have to work on both of them. So I try to distinguish them. So Daffodil I
Yes.
usually use to mean the software. DFDL I use to mean the language.
Okay. Well then, let me get back to our intro. So, Mike, you are the co-creator of the DFDL standard
Mhm.
and one of the driving forces behind the Daffodil open source project. Is that right?
Yes, you got that right.
Okay. Mike's career is like a Rosetta Stone for understanding legacy data systems, and he's been quietly solving some of the hardest problems in information sharing and secure interoperability for decades. He's been driving he's been a driving force behind DFDL, a champion of standards that actually work in the real world, and now he's heading into retirement, though we're not entirely convinced he'll stop building cool things. And this is our holiday episode, and I couldn't think of a better guest. I've been looking forward to this since Mike agreed. And just getting to talk to behind the scenes superheroes like Mike is a gift to me personally. And I hope it's a gift to everyone who's worked with or learned from him over the years. As one of Mike's longtime peers, Stephen Lawrence, put it, Mike didn't just solve hard problems, he helped the rest of us learn how to solve them too. So, whether you know him from Traces, OWL, the open standards world, or the Apache Daffodil community, you'll hear why Mike's legacy is so lasting and why his approach to collaboration, mentorship, and big thinking is exactly what this season is all about. So, officially, welcome to Tech Transforms, Mike.
Thank you. Thank you.
So, let's start at the beginning. What pulled you into the world of data formats and the secure systems in the first place?
Okay, well, so there's two parts of that. There's data formats and the secure systems. And I got
Hmm.
into data formats actually long before I got into cybersecurity. The first part of my career, once I got out of graduate school, I spent a little bit on artificial intelligence, but that was long before the current flurry of artificial intelligence. But then I did some work in big data before anyone coined the term big data and started talking about it as a thing. And I that's where I got into data formats because any system that wants to deal with data has to be able to import it from somewhere. And there's a
Hmm.
million different data formats out there. Now, some people are fortunate that, relational databases have become more and more data is in those kinds of systems and is better structured that way. But there's still tons of data in the world that's in various kinds of file formats. Now, used the term about earlier about legacy data formats, and it's true, some of them are legacy, but in many cases, the word legacy has a pejorative connotation, right? It's like
Right.
old formats, no one wants to use them. I
Really hard to
prefer to,
use.
right, I prefer to view them as the most successful data formats ever.
There you
Things
go.
that were invented in
Lasting.
1970s that are still delivering value today are
Mm,
amazingly successful and are worth some effort to continue to use, right? So anyway, so I spent from about 1995 to 2007 in big data, and the importing data into enterprise data systems and processing it fast, it was the problem. And data formats was a big part of that problem, right? Much bigger problem than people, it was always underestimated how difficult that problem was. You end up writing lots of custom software to deal with people's data. And it was, so we ended up writing some sort of description language that would allow us to describe data formats, but it was never really complete enough. We were always having to add stuff to it. And it turned into one of the biggest pieces of the whole software package we were building. So I started realizing that not only was my company investing in all that, everybody else in enterprise software was investing in that too, right? So so this is a problem because everyone's reinventing the wheel. Now, imagine you work for Oracle, IBM, one of these big companies, Microsoft, right? And you're acquiring smaller companies in the enterprise software space. Every one of them comes with their own whole data importer that describes data. You've got, IBM has probably 25 of these things in their product portfolio, and they're all different, right? So this is just a huge waste of reinvention of wheels inside of the software industry, right? You know, that became pretty clear to me that we really needed a standard here, that we were just reinventing the wheel endlessly. And in, you know, an awful lot of enterprise software systems, the you know, for data visualization or data cleansing, whatever they're for, the data import side is much harder than the other problem they're trying to solve, right? Just because people have been very creative over the years about all the clever ways of laying out data and passing data around and so forth. And so the data description problem of getting that into your system, it is as large as that whole legacy of invention from people for decades. Your business problem you're trying to solve with your software is probably a lot more specific, right? So nobody wants to invest most of their engineering team on this problem that most people don't even recognize is there, right? No one buys a data visualization software package and requests new features that are just about the data importer, right? They just expect that to work, right? So that's how I got into data formats. It turned out to be a huge thorn in our sides in working in enterprise software. Then, interestingly enough, when I left my data integration company, which was a startup that had been acquired, and I wanted to go off and do something else, and I got involved, found this Daffodil software project. And this was an open source project, already existed. It was run out of the University of Illinois, open source thing. And I started working on it. And at right about that same time, I found out that Traces, which is a company that has since become part of Owl Cyber Defense, was working with the government on this, unrelated to data integration and enterprise software systems, largely. It was about cybersecurity. And I was like, well, that's interesting. What's going on here, right? Turns out, okay, cybersecurity is kind of the killer app for this technology, right? Because people are tired of data coming into secure systems and crashing them, right? And bad data can crash systems, right? And so that's become the killer app. So
I
that's how it
imagine,
happened.
listening to you talk, I imagine a meeting of the United Nations. Like, we've got hundreds of people all speaking different languages. We're trying to solve a very important problem, but we can't because we can't understand each other.
Right.
And you really did help invent the Rosetta Stone to solve these hard problems.
Well, kind of. It's
Okay.
DFDL was the language DFDL was actually created because kind of the way standards ought to be created, which is we were just
Mm,
looking around at all these different tools that different companies had made and
hmm.
essentially making a union of their capabilities and deciding what the right name should be. So there's lots of
Ah,
names of properties and things in DFDL that are directly from some Microsoft product or some IBM product
hmm,
or whatever. So much of it was a synthesis from existing technology. So that
hmm.
part isn't invention as much as
You made it
standardization.
accessible.
Yes,
Yeah.
accessible and standardized. Now,
Yes.
that has a lot of advantages. I mean, once something is standardized, and then people can invest some career cycles into learning it because they
Hmm.
know they'll get some leverage out of it in their career, right? Whereas if it's, oh, I'm just using this IBM tool on this job, but in the future of my career, it'll be something else. Well, they don't
Mm,
want to worry about how data formats work in just one little corner of this whole space. They want to, so by standardizing it, you're making it into something that gives people more personal and career leverage, and it's
hmm.
worth it for they and their companies to invest in them learning it. So
Mm.
that's one of the things that is important about DFDL is it's not good when there's 46 different implementations of essentially the same idea, right?
Right.
We depend on that every day in our lives. I mean, you drive a car, the brake is to the left of the gas pedal.
Hmm.
Everyone knows that,
That's right.
right?
That's right.
And if it wasn't the case and there was 5 different orientations of pedals and so forth, it would be a lot harder to drive a car, right?
Yes.
So,
Every time I go to the UK, just having the
yes,
steering wheel
wrong
on the
side
other
of the
side.
road.
That's
Yes, wrong side of
right.
the road. Yet at least the pedals are the same positions, right?
Yeah. Yeah.
So,
There we go.
yeah,
There we go.
yeah, yeah.
So, over the years, was there a particular moment, maybe a win or a failure that really shaped your approach?
Yeah, it was both a win and a failure. So this is about 2000 and 2000, about the year 2000. I was working on a big data integration problem with a company called Axiom. And Axiom is one of the big data provider companies. You can buy data sets
Hmm.
from them that allow you to market products better and so on. And they of course process lots of data, and I was working for a company. We were selling them a framework for scalable computing, big data processing, and they made tremendous use of software from the SAS Institute. This is a statistical and data processing package, and we were trying to interface these things together. And the we had some problems with that. They had this big complicated record with 700 fields in it, something going wrong in the middle.
Hmm.
Debugging this problem is hard, right? And one of their senior engineers basically said, if this was a standard interface, we'd use a lot more of your software. And that's the reason why you want to do a standard,
Hmm.
right? It's not
Hmm.
because it's commoditizes something and then you can't make any money with it, because it enables people to use it more, right?
Yes.
So that was an aha moment for me. Was just like, oh yeah, this would be good for us to be the company that builds a standard thing and opens it
Hmm.
up to other people rather than, so that was, and now in the long run, we did not build a standard thing and give it to them. It's taken a lot longer to get that, right?
Hmm.
But they remained a customer, so it wasn't a win that day, but in
Hmm.
the long run, it's to our benefit.
Yeah. So, as you prepare to retire, what stands out as your proudest contribution or the thing that you are most glad you stuck with?
There's two answers to this. First is just the technical achievement of building this Daffodil software with the team of people, many at Owl, some people also from outside Owl, the open source team, getting it to be accepted as a top level project at the Apache Software Foundation. That was a
Hmm.
really important achievement because at that point things can snowball. People can find it. They can, So that's been pretty important, and I think probably is the major achievement. The other, though, I would say I'm really proud of the teaching that I've been able to do and the engineering leadership. It's really satisfying when you see people latch onto and start practicing ideas that you've through your career are hard won, right? You
Hmm.
eventually you had to go through lots of things before you landed on a set of practices that really work. And as you promote them, you see them being uptaken by the team. It's really satisfying to see. And of course,
Hmm.
I mean, all teachers in the world go through this experience of how satisfying teaching is. And
Hmm.
engineering, especially as you move to the later parts of your career, is a lot about teaching. So,
Well, and I quoted Stephen Lawrence, one of your peers. That's one of the things that he called out is your mentorship. And I talked to a few of your peers, and they all mentioned that. I will say that one of them said I'm going to paraphrase here, an incredible mentor, and a lot of us have become really good at the craft because of him, but there will only ever be one Mike Beckerle.
now there will only ever be one of me, but there are plenty of talented people who they just need the right direction and encouragement. And I'm always about encouraging people to, especially engineers need to trust their intuition and trust
Mm,
themselves and do things the way they think they should be done. And it's always satisfying when an engineer pings you on Teams or something. They want your opinion. They're not asking about something trivial. They're asking about something deep, right?
hmm.
That's what you want, right? The trivial stuff, they've got that down now, right?
Right.
The things they ask you about are the things where it's not clear what to do, right? So
Hmm.
that's always that's satisfying.
Well, and I know that your primary mentorship is towards engineers, but I remember the first time I reached out to you. You're incredibly generous with your time. You were incredibly patient with me, who had never heard of Daffodil or DFDL, and you broke it down for me in a way that I got it. I was like, yeah, this is amazing. And so, I mean, you mentored me, this
Well, this
woman
is
in
the
marketing. Yeah.
Yeah, well, I've had to deal with a lot of people in marketing throughout my career. I mean, I've been in front of customers every day of the week, or many times. I have been the traveling CTO that everyone in sales dragged around in front of the customers and did their job in PowerPoint.
Yes.
I lived that life for quite a while, and um, communication is probably the most important thing that's been in my career. Is it's
Mm,
really helpful to be able to talk to people. Oftentimes people don't they have requirements, but they're not that clear on them. They need a
right.
technical sounding board to really talk through them to
Mm,
understand what's really a requirement or to refine things. And that's the flip side of the marketing problem. How do you take these requirements or that system, turn it into something people recognize, right?
that's right.
So that's been something I've done throughout my career, and I'm proud of it. Yeah, I'm very happy of that. I've been able to do that for this organization, OWL, and others.
Yeah. Well, I personally appreciated it very much. You did not make me feel stupid. Um, you were incredibly patient, and like I said, at the end of our conversation, I got it.
Yeah, well,
So,
I'm glad you did, and I probably would have been very frustrated by the end of it, and would have been nagging you afterwards if you hadn't. So.
yeah.
Uh,
Well, I feel like you've explained really well what DFDL and Daffodil is. Is there anything else that you want to add, or what the impacts that you've seen come from this project?
well, I think the impact of this project, I mean, cybersecurity I mentioned is kind of the killer app for this, right? And people
Mm,
don't understand that, but that is going to really have some impact because, and I do it by analogy, when 15 years ago, using the internet, uh, um, everything was unencrypted because, encrypting everything would be too slow, right?
Mm-hmm.
Now everything's encrypted on the internet. It's very hard to even find a website that does not have a secure connection immediately, right?
Mm-hmm.
Um, and the next change of that kind is going to be this cybersecurity based on data descriptions, because before you allow data to connect, we're going to rip it apart based on its specification, put it back together, validate it, put it back together, then we'll let it through, right?
It
And
sounds
people
like
say
CDR. Is that what you're talking about?
CDR, I'm not sure.
Uh, I think I might be getting the acronym wrong. Glasswall does it.
Well, it's Glasswall is another vendor in the cybersecurity space, yes. But
Right.
this is what OWL and other vendors are all doing using DFDL. The idea is you don't allow data in unless you've proven what it is. It's not like what is it labeled, what is it pretending
That's
to
right.
be.
It's
You're
true
gonna
zero
take
trust.
It's true zero trust. You're going
Yeah.
to rip this data down to its atomic pieces, strings and numbers and so on, put it back together according to specification. By construction, it definitely is one of those things now. And if it doesn't survive that, you don't let it through, right? So that is the next level of security above the encryption layer, right? Is the data has to be what it says it is, and otherwise
Right.
it's not allowed through. And that's going to actually make a huge difference, because there's this thing called a bad data denial of service attack. And it doesn't matter if you're a website or a military system. If data's coming in,
Mm-hmm.
and flawed data might just, depending on how it's flawed, crash that software. That's a
Mm-hmm.
denial of service attack, a
Right.
successful one, because you got to
Right.
restart that system or reboot or something. It's offline for a while, right?
Mm-hmm.
And so it's not a computer virus. It's not malware. It's just bad data, right? Boom. You can actually have
That brings it
significant
down.
impact. Yeah.
Right. Right.
So that's going to have some real impact, because systems are just going to be more robust as a result.
Yeah. Okay. I did my fact checking. It
Mhm.
is CDR. It's content disarm and reconstruction. And
Exactly.
that's
That's
what you
that's
just exactly described, right?
yeah. I
So
didn't coin that acronym, but it's what I've been referring to as rip and rebuild.
there you
That
go. So you're saying that's your prediction that that's going to come for every website,
yeah,
every interaction online is going
yeah.
to include rip and what did you say? Rip and rebuild?
Rip and rebuild. Yes,
Rip and
it's
rebuild
it,
R&R. I like it.
yeah. So the idea is that basically, yeah, you have to trust the data. It works on the outbound side too. When people are sending data out, um, you want to make sure the data you're sending out is in what we call canonical form, which is to
Mhm.
say it meets all the requirements that anybody could be expecting of that data. But furthermore, there's a lot of data formats, they've got little sections in them that are unused.
Mhm.
Um, or they have parts where it can be, we can have carriage return line feeds or regular line feeds, any kind of those things is allowed. Well, canonical form standardizes all that. And what's really important is that blocks covert channels. So that's another
Mm.
important aspect of cybersecurity, is that if data can be exfiltrated from a secure environment by reusing all these little bits and parts of the data, then they've really got an exploit. They can steal from you,
Mhm.
right? And using DFDL and this rip and rebuild process, you get canonical data. All those little things they're trying to exploit are gone, so they can't
Yeah.
exfiltrate data that way. And so
Oh,
it's important that way as well.
I just had a aha moment, I think. So when you rip and rebuild, you rebuild in DFDL?
Yeah, that's what DFDL is for. We write
Okay.
a description of the data format.
Right.
We use it to break the data down into a data structure,
Mhm.
where all the little strings and numbers and everything are all separated out. Then we
Mhm.
use that schema again to put it back together into its original form.
Hmm.
but it's not exactly bit for bit identical. It's in canonical form, which is to say, like, let's say you had some data where you could separate the fields with either a comma or a semicolon. Well,
Hmm.
pick one of those. One of them is going to be the what you're going to get out. It's going to be all commas, or it's going to be all semicolons, but it's only going to be one of them, and that prevents you from transmitting information based on comma versus semicolon and so on.
Right.
So
Right.
that once the data has been, that's the killer app for DFDL is parse the data, break it down, put it back together, and which it is, we looked at it, was like, oh, well, you're going to parse the data, but then just put it back together. What do you do? This is the value it's providing in cybersecurity is that the data is guaranteed to be what it says it is. And bad data generally just doesn't survive the process. And so it
Mm,
can be blocked.
right. Talk to me about doing this in open source. I
Yeah.
it
So yeah,
it
that's a good
feels
point.
like it's counterintuitive to building a business, first of all, to just give it away for free. It
Mhm.
also feels like it could be incredibly insecure because you've got, you know, dirty little paws touching it. So
Yeah.
help me understand.
Yeah. That's actually been a really rewarding experience for me because I've been at big companies, and even companies as big as IBM had a terrible time trying to build reusable software components and have a supported business unit that does that makes them on behalf of all the other products that need them.
Hmm.
Uh, it's because business units are very reluctant to ascribe some of their revenue to a different business unit, right? For all
Right.
the business reasons, right?
That's
And
right.
so even organizations, I mean, I haven't worked for them for a long time, but when I last worked there, they couldn't make that work. Right. They
Mm-hmm.
had these blue dollars thing where it's not real money, but you're paying, it boils down to at that time anyway, wasn't really successful. And um, but what has been successful is open source software, and
Hmm.
and it's successful for two reasons. One is because you don't have to pay for it, and therefore people can use it. Right? It the and so there's no resistance to using it in some
Hmm.
sense. It just has to be of high enough quality. So then that
Hmm.
brings me to your second point about people's paws being all over it, right? So that cuts both ways, right?
Yeah.
People's eyes are also on it. Their paws are kind of restricted because open source projects use a software development lifecycle with enforced code review.
Mm.
There's a trusted team of people who only bring in new contributors gradually based on their proof of they can actually, they make some contributions which other people integrate into the base for a while. And eventually people become trusted to contribute high quality code. But
Uh,
everything goes through a life cycle where two people who are authorized, and that's my phone ringing. Sorry, I will silence that somehow. Yes, and put this on do not disturb, um, which I forgot to do at the beginning. Sorry. Um, okay, so there's a lot software development lifecycle where two people, trusted contributors to the project, have to review every change,
all right.
right? So there's absolutely no way someone can inject, backdoors or other things, or just crappy code. Most
Right.
uh, most uh, uh, most open source projects have like Daffodil, for example, have a policy that, oh, you can't check in stuff if it doesn't also include tests that show it works,
Mm.
right? And that show both sides of positive and negative examples and so on. So it allows you, and since it's open source, there's no the pressure to just put it in and hope it works. That's gone.
Hmm.
You basically have to say, no, you're going to prove it works for us because
Hmm.
we know we have to keep it working too. So the tests are every bit as important as the code, right?
Mm.
And so
Everybody's got some skin in the game to
well,
make
yeah,
sure. Yeah.
test-driven development is one of the things that throughout my career I've learned is really essential, right?
Hmm.
You have to make people think about the problem from the testing and build right into every change they make. Think about, oh, how am I going to test that this actually works?
Hmm.
And sometimes that even affects the design of the thing because you have to design it not only to work, but so it can be tested and you can show it works,
Right.
right? And that's so open source really encourages all of that and
Hmm.
enables all of that. And you know, there's anyway, that I've been very impressed by the sort of state of the art um, life cycle and software development methodologies that just come out of open source development.
Hmm.
Particularly, I've only worked with the Apache Software Foundation, but they have a methodology that is referred to mystically as the Apache way, right?
Oh, I
But
like that.
this is all part of it, right? It's a meritocracy. People are admitted based on their merit. There's
Oh,
all this
wow. It's
built-in
like
code review.
it's a club. It's
It's a
no
club.
more. Yeah, yeah. With
Yeah,
some
it's
really
I wouldn't.
strict entry.
Yeah, it's not a cult. It's a club.
No, it's a club. It's a club.
Yeah, but it's become a very big club. I mean, this
Yeah.
software is now in use. There's hundreds and hundreds of these open source projects under that umbrella, and they're in use. I mean, you hardly use anything in your life anymore that has technology in it that is not using open source software.
Mm,
So
yeah.
it's I doubt you could find something that doesn't have any open source software in it.
Mm. Well, and it makes me think of what you said earlier. This standardization is incredibly valuable and necessary for us to continue to progress.
Mhm. Yeah,
So
without
you,
it, you reinvent the wheel too often, and it
right.
slows you down.
Well, I think we would kind of just be spinning. We would just
Yeah,
turn,
exactly.
right?
Right. Hmm.
You've worked in some highly constrained environments, defense systems,
Yeah.
legacy data, which we will rename seasoned data, secure,
Yeah. High value data or
high
something.
value
Yeah.
data that's really stood the test of time, secure domains. What's your approach when you're faced with a problem that most people would just say, yeah, that's impossible?
Well, I have made that observation in some cases in my life, but I do believe few problems are too hard um, if you really understand them and you drill into what are the requirements. I
Mm,
mean, painted very broadly, you know, artificial intelligence is too hard. People have built systems; they're clearly intelligent, right? So they figured out what how to refine that box and do things that are really useful, right? And most problems are like that. If you have to bring an engineering mindset to how do we break this down to make it not too hard. So,
mm,
you know, I like to bring, you know, from my educational background, I did a lot of work on languages and compilers, and I bring that toolkit with me to almost every problem I solve. So, um, and I like to use that to solve problems that most people would try to solve just by coding and having more programmers work on the problem. So, so that's kind of been important. A good example is we deal with a lot of these very large, high value data formats, and
hmm.
they have big specifications. I mean, one of them, the spec is 13,000 pages. Okay, I
Oh,
kid you not.
wow.
It hasn't been printed out in decades because no one could ever print it, right?
Right.
Now, I had heard estimates from one of the aerospace contractors that, you know, oh, implementing that thing is, you know, 20-30 million dollars, right?
Hmm.
So what did we do? Well, we wrote a parser for the format specification document using DFDL to parse that document, treating it like a very loosely structured piece of data. Then we converted the output of that into a DFDL schema that implements that format. So we are compiling that spec into the thing that we need, right?
Hmm.
And that approach, as opposed to a bunch of people are reading the spec and just trying to write code for it, has tremendous leverage.
Right.
Huge numbers of quality assurance issues just because programmers will make mistakes in sort of random places, right?
Mm-hmm.
Go away because what comes out of this compiler approach is much more uniform. A whole aspect of how the thing works is either going to work everywhere or fail everywhere, right?
Mm-hmm.
And then you fix it in the compiler in one place, and now it works everywhere, right? And so it changes. It changes the approach to that. And of course, we spent a fraction of $1 million on that project.
Yeah.
So it's a high leverage approach, and engineers who glom onto this and start using it immediately catch on to the idea. They're like, oh yeah, of course this is the way you should do this, right?
Mm-hmm.
And so that's one of the things that, of course, the teams I've been working with all take away is that, oh, we should definitely be thinking about compile something, don't write it.
Right.
So
So you took a different perspective, like to use the horrible adage, there's more than one way to skin a cat.
yeah, that's right. There's more than one way, and sometimes you can come up with a way that's that just has a huge benefit over the ordinary way.
Mm-hmm.
So,
Well, you've mentioned many of the organizational cultures that you've been part of, IBM, Traces, Owl. What do you think makes a truly good team that can really cause technical transformation or affect technical transformation?
well, that's an interesting point, and uh, the um, one of the things is having a um, it's been referred to as a good geek culture.
Mm.
um, Engineers get to be pretty geeky, but the key is not just to be um, socially awkward in the way many of us geeky types are. No, the idea is that the engineering drives a lot of the decision making. Right?
Hmm.
Engineers, in some sense, have to learn to listen to their own counsel as
Mm.
much as they listen to outside influences asking them to do stuff, right?
Hmm.
Because oftentimes what you have to do to the code, half of that is in the code. It has to happen, right?
Hmm.
And you just have to say, no, this actually has to get done before we can do that other thing. You actually have to um, uh, you have to let the engineering drive the agenda, not exclusively. Businesses are in business to do something, right?
Right.
But once you start building a piece of software in order to achieve something, it starts to have its own structure and shape, and you actually have to pay attention to that so that otherwise you end up uh, with a group that doesn't really you're not really working on something that has any cohesiveness to it,
Hmm.
and
Hmm.
that's really important because once you've built something, it's got some cohesive to it. Now you can get some business leverage from it, right? Because it's not a big monster that no one really understands. It's something that you can actually bring to bear on lots of problems. So,
And it makes me think of what you said earlier about the importance of being a good communicator.
yeah.
So you just mentioned, engineers are, it's really important to have the geeky aspect. I agree.
Mm.
And you have to be able to communicate the value of what you're doing beyond the beyond the geek group that understands it intuitively, and it's what they live and breathe. You have to be
Mhm.
able to communicate that value, and it's something that you do very well.
Yeah, that's been my role. But there's plenty of
Yeah.
engineers who are very excellent programmers, not and excellent engineers, and not as good at that stuff. And you
Hmm.
do have to sort of nudge them to do more of it because they might be fine at it. They just don't think they are, right?
Hmm. Right.
And the other though is that, you know, you need some diverse people in an engineering group, and then people gravitate to the roles that their talents, you know, select for them. And that's
Hmm.
all okay too, right? Not everybody has to be the spokesman for the group,
That's
right?
right.
Or the customer interface for the group. Not everyone. So,
That's right. That's a very good point. As you step away from the day to day, what advice do you want to give to the next generation of architects and system engineers?
you know, this is something I have been giving some thought to. And to me, the lesson I've learned across my career, that it's a little, is, um, is don't be too clever. So,
Mm,
and I've numerous times in my career, and recently even I was advising another engineer at Owl about this, as they business comes to you with a customer problem.
hmm.
And so you think about it for a while and you go, you know, we could just do this and this and this and this. And you come up with some very clever way to enable some aspect of the software system you've got to address this new endeavor that the customer has. And the challenge is you figured out how you can make it work. You have not taken into account that that is going to live forever once you put it in the code base. It has to be
Mm,
documented. Other people have to understand it. Can you sell it again, or are you doing all of that for one deal, right? Because one of the challenges with engineering is you don't get to scale your engineering workforce with your customer base. You get
hmm.
to grow it, but you're supposed to get some leverage from it. You're not building
Right.
custom one-offs for everyone, right?
Right.
And I've designed some very clever things in my time that in hindsight, I was like, we really shouldn't have done that. We should have just focused on what was more important for the product that we were selling in volume, not
Yes.
helping to close that one more deal or cajole, you know, whatever. And it may not even work to close that deal.
Right.
Or and you might not even know how important it is, right? Like if you had just told the salespeople and executives who came to you with that problem, you said, that's pretty hard to do. I'm going to need a week to go think about it. They may never have come back to you. But
Hmm.
instead, you spent all this time and effort coming up with this very clever thing and maybe even prototyping it and all this stuff that is just going to create a headache for your whole organization down the road.
Yes.
So,
To
so that's
maintain
why
it.
I say, right.
Yeah.
So this is why is don't be too clever. The notion is because being too clever bypasses too much of what you really have to think about as an engineer, which is
Hmm.
this got to be maintainable. How are we going to test this? You know, is there, you know, and those things, a lot of them have the fact that you're building something you're going to sell multiple times
Hmm.
is it drives that, right?
Hmm.
If you're just building something for one use, well, you could test it on site or something.
Right.
You know,
Right.
there's shortcuts like that, but you know, you're going to end up with your engineering team on site to do this one little thing instead of getting leverage from the engineering.
Mm. So don't be too clever. It makes me think of Dr. Seuss analogies. Specifically, my niece loves the newest Grinch. It's
Mhm.
been out for a few years, but it's animated and it's got Benedict Cumberbatch is the Grinch. And he
Mhm.
builds all these inventions, and they're just like these crazy, really clever inventions, really complex to make a piece of toast. And
Yeah,
you know, and they
right.
break really easily. And so
Rube,
as
these
you're,
are, am I dating myself? These are called Rube Goldberg
yes, yes, exactly.
contraptions, right? And
Yes.
I think I'm not even sure where that comes from. Is it from
It's
cartoons in the New Yorker or something?
the Rube.
Yeah,
Well, I mean, I've seen some of his like mazes in action and they're fascinating to watch.
yeah,
Um, but they're kind of a piece of art to look at rather than
yeah,
solving a problem. Like just put the
yeah,
toast in the toaster.
right.
That's all you need to
Yeah,
do.
yeah, and when engineers are being clever, they're not necessarily creating Rube Goldberg contraptions, but
Hmm.
but the analogy is apt because they're building something that is not going to be maintainable, at
Right.
least not easily, and that is not going to be easy to explain to anyone because it's got so many aspects to it, right?
Mm-hmm.
And so yeah, it's clever, it's inventive, you may get good ideas out of it, but it's not really engineering, right? I
Right.
mean, engineering has we have to, if you're trying to you have to do something that is going to hold up to scrutiny when you're
Right.
engineering,
Right.
right? So
What do you hope continues to grow from your work on DFDL and Daffodil?
well, the cybersecurity enhancement that I talked about earlier, that people doing the rip and rebuild on all the data and so forth, that's the legacy of this that I think should I'm hoping will, things always take longer than you expect, but I'm hoping that's one of the least long legacies from this stuff,
Mm-hmm.
because it's really that's been what Owl and other companies and the U.S. government and so forth have been investing in by trying to get this DFDL technology out there.
Mm-hmm.
So I think that's the thing I'm really hoping to watch as I go through the next cycle of my life here. I will be have my fingers in this stuff a little bit still, no
I
question. But
I know. I'm thinking that. I'm like, we both know that you're not done.
yeah,
Is that the problem? If you could solve one last problem, is that it? Would you do the rip and rebuild?
no, the rip and rebuild is happening. I
Yeah.
don't need to do that. There is a sort of a barrier to the uptake of the DFDL and Daffodil stuff, and it's it, it's because it's highly dependent on um, XML and XML schema technology. And that technology is modern engineers nowadays, they have a love-hate relationship with that stuff. A lot of
Mm.
them just try and avoid it like the plague. It's like one more thing, Baroque thing I don't have to learn. Um,
Mm-hmm.
and other people are using it effectively and like it. But there's certainly plenty of people I've run into in the Apache Software Foundation at their conferences and so forth. And I explain to them what DFDL is about, and they're all about it. They think this is
Mm.
great. I want to use this, until they realize it's using XML and XML schema technology. And then they're like, oh, I don't want to have to, I mean, literally, you could see it in their faces. They're just not that interested in that stuff. They
Yeah.
want something more familiar, easy to use than that, doesn't have the learning curve all that stuff has. And
Mm-hmm.
so we have this on our roadmap for the Daffodil project, which is to invent a different, more familiar kind of syntax for describing these schemas and not making people have to use XML schema and so forth to do this. I think that's important to the success of this technology, so that um, uh, because there's a lot of people who want what DFDL does. They don't want to do it in terms of the whole XML technology
Mm.
stack.
Right. They want it to be
And
easier.
yeah, and they want it, well, easier and free of. There's a lot of stuff that comes along with using
Mm-hmm.
XML. It's verbose. It has some overhead problems. You have to buy into that. The syntax is pretty verbose, so it takes you a while to even get to learn to read it because it's kind of
Mm.
verbose. And if we can fix that, then I think lots more people would latch onto this. So,
Okay.
there's a group of engineers who are kind of on the fence about it, and I'd like them to be able to adopt it enthusiastically.
All right. Well, we'll be watching for that.
Yeah.
So now we're to our tech talk question part of the show. This is rapid, fun, just
Okay.
rapid fire, fun questions. So if DFDL were a tool in a sci-fi toolkit, what would it be used for?
Sci-fi toolkit. Um,
Hmm.
so in my mind is an episode of like a sci-fi show, like spoof, like Doctor Who, and
Yes.
in the back room there would be like these two ancient computers with this cable that they have to connect them with, and guys on the trying to type the DFDL schema for the data interchange, in order to keep the spaceship from crashing or something, it would be, and it would be, these ancient computers that they have to keep working
Right.
because no one knows how they work anymore or something,
Right. Or could it be Doctor Who's Sonic? Is that what DFDL could be? Like his Sonic can do anything. It can translate anything. It can fix anything. All right.
There is a saying in the engineering world, which is if you have a big enough hammer, everything looks like a nail.
There you go.
And so DFDL is like that. It's like, oh, well, you can describe that kind of data. Well, then you can do all this other stuff too, so it can do a lot.
Okay, but I feel really happy about saying that it would be Doctor Who's Sonic Screwdriver because it can do anything. Yeah.
Yeah, almost.
All right. What's one ancient technology you admire for its cleverness or durability?
Okay, well, one of the data formats we deal with is a thing called Link 16, which is this thing been invented in the 1970s for communicating between aircraft.
Mm-hmm.
And it's intended to be unblockable, unstoppable. And the radio layer that's in this, it's incredibly clever. They jump frequencies, which is this thing that was invented by this actress, Hedy Lamarr. She was actually an inventor. So they don't only jump frequencies, they have time slots, and they jump around the time slots. So any given communication is in this hodgepodge of different places in the spectrum and the time that data is moving. I was just very impressed by it. It was like, that's one of the coolest things I've seen in a long time. There's no way you can block, jam, or intercept this stuff. It's just unfathomable to me.
Yeah.
So I thought that was really, really cool. That's certainly one of the most clever things when I read that spec. I really liked it.
Nice. All right, last one. What's a myth about data standards that you wish would disappear forever?
Myth about data standards. People think data obeys its specifications. For the most part, we have never, I would say in my entire career, I have never seen a project where the data actually matched the specification perfectly.
It's like a child.
Well, the specifications are documents written by people. There are mistakes in them, right? And so the de facto data, the data that's on the wires going between the computers, right, seldom matches the spec completely. So that means, and so if you have just the specification, and you build a schema for parsing that data format, it's not going to work. There will be something you'll have to debug in it.
Yeah.
Right. And people somehow think that if you just have the spec, you've got what you need. Right. But you actually have to have de facto test data because there's always a discrepancy. Right. And that's certainly a myth. People think that data is better coherent, is better matched up to they think that it's only data that's really, really old and specifications that have gone through many revisions that you have any chance of them actually lining up perfectly.
Yeah, it is. It's like being a parent. You read these books, your child does not follow one of those rules, right?
Oh yeah. Not
one.
Right. Well, yeah, no, in data, it's not as bad as that. Most of the time, the spec is, probably 95% correct. But it means that when you get my friends in the military say, no plan survives first contact with the enemy. Right. And this is the data version of that. It's no data schema survives first contact with real data. Right? You have to plan to debug it with real data.
I love it. All right, Mike, where can listeners go to learn more about your work or the Daffodil project?
The best starting point you can, of course, you can go to Owl's website, but I always tell people go to Wikipedia
Ah,
And you should
okay.
donate $10 a year for Wikipedia because it's the best thing ever. But go to Wikipedia and type DFDL. That there are some other things in the world named DFDL. So, but if you type DFDL data format at Wikipedia, that will take you to an article about DFDL with links to all the different stuff,
Hmm.
our implementation, Apache Daffodil, the spec. There's other companies that have implementations. IBM has 3 different implementations, right?
Hmm.
And there's links to all of that stuff. That's the easiest place to start.
Okay. Well, thank you so much for doing this with me today.
You're welcome, Carolyn. Thank you so much.
Yeah. And thank you, listeners, for joining. Please share this episode, smash that like button, leave us a review so we can continue to share this kind of content. Um, Tech Transforms is produced by Show and Tell. Happy holidays. Until next time, stay curious and keep imagining the future.